Okay, the next example of a machine that we are going to treat now is the pulley system. Is also called block and tackle system. So in your question, it depends. If they call it block and tackle, they are still referring to pulley. Now, the only thing, like I said, we are supposed to know, just like we treated the velocity ratio of lever, the only thing we need to know about each machine from now on is the velocity ratios. So the velocity ratio of a pulley, system, or you call it block and tackle, is the number of pulleys. The number of pulleys. That is what you call the velocity ratio. Velocity ratio of a pulley system is the number of pulleys. So what are the number of pulleys you have here? In this particular diagram, it happens to be 3. So we have 1, 2, 3. These are what we call the pulleys. 1, 2, 3. You apply your effort here to lift a load here. Just a little effort lifts this big load. So our velocity ratio, according to this particular diagram, is 3. So have you seen why I say that? Because what is velocity ratio? Distance moved by effort divided by distance moved by load. So as you can see now, the distance moved by this effort is from here to this point. From here. So you have to overcome 1, 2, 3. While this load, you just lift it up. So load is always divided by 1. The distance moved by load is 1. Just one distance. So this will give you 3 divided by 1 will always give you 3. So instead of dividing this by 1, just know that it is equal to the number of pulleys. So the velocity ratio of a pulley is equal to this. The efficiency formula still remains the same. Mechanical advantage formula still remains the same. But for velocity ratio, it changes. So number of pulleys equal to the velocity ratio. So we are going to solve a question now to see how to apply this. Okay, this is an example that we can use to illustrate how to solve questions on a pulley. Just one question. Then for more exercises, click on the exercises section and you get enough questions concerning this. Okay, so pay attention here. I'm going to use this to explain it better. This is hands. Okay, now the first question, the question says here, a block and tackle system of pulleys with a velocity ratio of 4. So in this particular one, we are given the velocity ratio already. A velocity ratio of 4 pulleys is used to raise a load of 400 Newton through a height of 15 meters. If the total work done against friction, so there is friction, so it's not a perfect, this pulley is not a perfect pulley, so there is friction. So if the total work done against friction in the pulley is 700 joules, calculate, now we have the following. I say the total work done by the effort, II, the efficiency of the system, I, the effort applied. So we are going to take it gradually, small. The first one says the total work done by the effort. Now, work done by the effort is effort times the distance moved. So let's see what happens now. Now, I'm going to clean here. Put down our solution, the total work done by the effort. What we already know is that we have the total work done by the effort against friction. The total work done against friction already. So what we don't know is the work done by this pulley, by lifting this pulley. We don't know that, but we know the load. We know the load and we know the height. This load moved. We know the load and the height, the load moves. So the total work done is supposed to be everything. If you are trying to lift something now, it's supposed to be the distance covered by the pulley, which is the number of pulleys. Now, the distance covered, okay, the height was covered, which is 15, and the force times distance. So we have 400 times. So for you to overcome this particular load, this was covered. So we have 15 meters plus, this is not a perfect machine. We are told that there is another effort that is being applied to overcome friction. That work done to overcome friction is 700 joules. So the total work done in this particular pulley is the work done by effort on the pulley, which is this, plus the work done by effort to overcome this particular friction. So what is that work done? 700. So we have 400 times 15. 400 times 15, if you punch your calculator, will give you 6,000 plus 700. So the total work done by the effort in this particular system is 6,700 joules. 6,700 joules. Please, this is how to solve this particular question. This is what will happen. This times the height, the load covered, plus the work done against friction. Now question 2 says efficiency of the system. The efficiency of the system. So how do we calculate the efficiency of the system? Remember, the efficiency has two formulas. We have efficiency is equal to work output over work input times 100 over 1, or mechanical advantage over velocity ratio times 100 over 1. So in this case now, we can use the second formula. From what we have here now, we only know the velocity ratio, which is 4. We don't know the mechanical advantage and we don't know the efficiency. So you can't be looking for two unknowns in a particular equation. So the second formula will not work. So we are going to make use of the first formula, which says that efficiency is equal to work output over work input times 100 over 1. Work output over work input. What is work output? The work output is the work done by what? Load. What is the work done by load? 400 times force times distance, 15, divided by, what is the work input? The work input is what we just worked at, the total work input, which is the work done by effort. So, and we have gotten that to the 6,700 times 100 over 1. So this times this will give us that our efficiency is 6,000 divided by 6,700 times 100 over 1. So if we point this in our calculator, what do we have? So everything will be giving us 89.6%. 89.6%. That is the efficiency. Please be very, very careful with this. The work output is the work done by the load. What is work done by load? Work done is force times what? Distance. This is the force times the distance covered by the load. Then divided by work input, the total work input you have solved is the work done by friction plus the work done already to leave the load, which we have calculated everything we sum to get 6,700 times this. Punch your calculator. This is your answer. Remember, efficiency can never be greater than 100. It can never be greater than 100. It's either it is 100 or less than what? 100. So we are going to solve question III. Now the III says the effort applied. This is a technical question. The effort applied. And we know that from all the formula concerning machine, the only place you can see effort is in mechanical advantage. Because we are told that mechanical advantage is equal to load over effort. And that is what we are looking for, the effort applied. So we can't get the effort applied if you don't know the mechanical advantage. So we know the load already, but we need to get the mechanical advantage. Another thing we know is that we know the velocity ratio to be 4. Now we have gotten the efficiency of the machine. So what we need to do now is to get the mechanical advantage. So how do we do that? is equal to mechanical advantage divided by velocity ratio times 100 over 1. Okay? So with this, we know everything in this formula apart from this, so we can get mechanical advantage. So what we just need to do is, what is our efficiency? 89. Now, watch please. What we got, our efficiency is 89.6%. If you want to make use of 89.6 direct, you have to maintain 100. Look at what I mean by that. If you are writing 89.6, this will be mechanical advantage over velocity ratio is 4 times 100 over 1. But if you don't want to make use of this 100, you just divide this straight by 100, then remove 100. Depends on your choice. Okay, look at what I mean by that. I can simply punch in my calculator 89 divided by 100. So that will give me 0.896 is equal to mechanical advantage divided by 4. So this is always easier. Even for the jam bites, it's always easier to divide your percentage by 100 and remove the percentage aspect. So what do? We just cross multiply. So I'm going to clean. Now if you cross multiply, you now have that your mechanical advantage is equal to 0.896 times 4. Remember, mechanical advantage has no unit. Velocity ratio also has no unit. So we have this times 4. So this will give us 3.584. So our mechanical advantage is 3.584. Now we can now come to our formula and get our effort. Remember, mechanical advantage, as it is on the board, is load over effort. So what we need to do now is to make effort the subject of the formula. Now effort will give us load divided by mechanical advantage. Load divided by mechanical advantage. What is the load? From the question, the load is 400 Newton. While our mechanical advantage now is 3.584. So if you divide this, you get the effort applied. So we have 400 divided by 3.584. So we have 111.6 Newton. So have you seen? That is the benefit of what machine helps us in real life. Imagine a load of 400 Newton for you to lift it with a pulley. You don't need to apply a small effort. 111.6 Newton. To the nearest whole number, you can say 112 Newton. Just 112 Newton to overcome a very big load. So this is what we have. If you have any question, drop it in the comment section. For more exercises, click on your exercises and you see more exercises on this.